The nature of magnetism. Magnets were first discovered over 2,000 years ago by the Chinese and the Greeks and were used for various non-scientific purposes. The name comes from the Greeks, as certain magnetic rocks, such as magnetite, were found in the province of Magnesia. Unlike electrical effects, due to the rubbing of various substances, like amber for example, to separate the electrical charges so that there would be attractive and repulsive forces, the magnets came out of the ground already attracting and repelling certain materials. It wasn't until 1000 AD that Chinese, European, and Persian mariners separately used magnets for navigation. When a magnetic material was formed in the shape of a needle and floated on the surface of water, it always pointed in the same direction, towards the north. And what was created there? Well, a compass, right? Here's the compass needle here, and it always points to the north. Always being able to tell which direction was north was a critical factor in ushering in the age of exploration. It wasn't until 1600 when this phenomenon was explained by William Gilbert. Magnets have two ends, which we will call poles, called north and south, and that's analogous to charges which have positive and negative. Like poles repel, just like charges, unlike poles attract. This attraction or repulsion is a magnetic force. We're not dealing with electric forces now. This is a magnetic force. When a magnet is cut in half, or any fraction frankly, each piece still has a north and a south pole. No matter how many times the magnet is cut, the pieces still have a north and south pole. That's illustrated in this picture down here. You have one magnet, cut it in half. Both magnets now have a north and south pole. Cut it again. All four magnets have north and south poles. This works all the way down to the atomic level. And we've already said this, but it's worth saying again. The behavior of magnetic poles, which are north and south, is similar to electric charges, which are positive and negative. Opposite poles attract and like poles repel, just like opposite charges attract and like charges repel. However, there is a significant difference between these effects. You can find independent positive and negative charges, for example, a proton and an electron. But magnetic materials always contain a north and south pole. You cannot find a north pole all by itself or a south pole all by itself.